Hello, I'm Graham and I hope everyone's having a great day. Welcome to this video in which I'm looking at repurposing flash units for use with your bridge cameras. Now in this case we'll be looking at the Panasonic bridge camera, but it doesn't really matter which camera we're talking about as they all will work in the same way. Now over the years I've had digital cameras or film cameras. I've bought the manufacturer's flash unit for that particular camera. So when I had Nikon units, I had the Nikon flash guns. Now that I got Canon, I switched over to Canon flash units. And with the Panasonic, I bought the Panasonic ones or the Godox range, which are Panasonic compatible. So I've got quite an array of flash units. And I thought it would be a shame not to be able to repurpose those to use them in the studio for fill lights or backlights or hair lights. And you can do that in very many ways. So first of all, let's look at how we can repurpose any manufacturer's gun to work on the camera. Well, first of all, it's down to the hot shoe configuration, and each manufacturer has a different hot shoe configuration dependent on the type of data that it wants to communicate between the flash unit and the camera. Now, some units have got 4 pins, some units have got 5, some have got 6. It depends again on the manufacturer, and they all have different placements. So you may find that the Canon and the Panasonic ones align perfectly, but the Nikon doesn't align with either of those two. So there are some disparities. The main pulse is fired from the central electrode respect to ground. So the central electrode pulls the flash trigger voltage down to 0, and that causes the flash to fire. The other pins are used for data communication, so they're very low voltage and very low current. Now it depends on the shoe interface, whether the pins are aligned with the camera that you're using or not, but in general terms you won't have any issue with the data pins causing problems or destroying the flash or the camera because of that contact. If you are worried, then you can get these pass-through hot shoes which have only got a central electrode and a top electrode, and none of those data pins will actually come into contact with the camera or the flash unit. But if you wanted to use that, then that's an option. It does mean that you're extending the flash unit a little bit further off of the camera, so you're applying a little bit more pressure to the top of the camera through the leverage effect. But if you want safety, then use one of these dumb hot shoe adapters. We can use the flash unit directly on top of the camera. So for example, with the Panasonic system, if I slide on this Canon flash unit and I take an exposure, let's set this into the manual mode. So we're in manual mode, 1 power, the power set to 1/128. So when I fire the camera, the flash will fire as you would expect it to. So if I change out the Canon unit for this old Minolta system. Minolta was bought out by Sony, if you remember, some years ago, but the old Minolta system had the standard hot shoe, where they now Sony have got the proprietary type. So again, with this flash unit mounted on the camera, it will fire with the center pin. So that will apply to the Nikon as well. So you can use them directly on camera. You will vary the exposure by varying the power of the flash and the aperture in your camera. Remember, those are the only two components which will affect your flash exposure. Flash power, which is really flash duration, and the aperture you've set on the camera. With most of these guns now you can go down to 1/128th power. With the old Minolta one you can only go down to 16th power unless you go into the motor drive unit, which gives you a shorter pulse. So you have the opportunity of changing flash power and aperture to get your exposure right. If you're still finding that the camera flash is too powerful, then of course you can fit ND filters to the front of the camera, and that will then change your exposure as you would expect it to. If we don't use the flash on camera and we wanted to use it remotely, because our pop-up flash is going to be using the TTL exposure, it will use a pre-flash to determine that exposure. So when the pre-flash goes off, if we don't set up our flash unit to be in a slave mode, which will suppress that pre-flash, the slave flash will fire when it sees the pre-flash and it won't contribute to the exposure. So if we're using TTL pop-up flash, we must set our slave unit into what's called the S2 mode. And the S2 mode suppresses that first flash. So I've set that up now to the S2 mode. So when I fire the camera, the pre-flash will determine the exposure, the power level for the main flash on the camera, and then my slave trigger, which I can set to a variable power, will contribute to the exposure. So the pre-flash happened, it determined the exposure of the main flash, and then when the main flash went off, the slave flash applied its exposure to that image. So you can vary the amount of power on your flash or its distance to your subject to vary that amount of contribution to the exposure. It's better if you want to use two flashes to put another flash unit on the camera in the manual mode, use that to set the main exposure, and then another flash in the S1 mode so it will fire synchronously with the main flash, and then you can vary the power on that second flash to give you the fill that you require. And then you can expand that to your backlight or hairlight to give you the amount of flash exposures you want. So how would you actually do that? You could use optical triggering on all the systems, so you could have 4 flash units all triggering on the S1 and all at different powers to give you the exposure you want. Or you could actually use radio triggers. Now, radio triggers have an advantage over the optical trigger that you can actually use them outside in sunlight. Remember, the optical trigger uses that light post to fire the exposure, so if the slave flash can't see that main post because of the brightness of the sun shining on its sensor, it won't fire. So in that situation, a radio trigger is ideal. Now these are very cheap, the cheap ones, less than £10 or $15 if you like, and they just consist of a simple transmitter and a simple receiver, and most of these have got 4 channels, so you can set them up on 1 of 4 channels if you're having problems with interference from either another unit or from local interference. So they just slip on top of the camera. So with the transmitter mounted on the camera, when the shutter fires, it sends a radio signal from the transmitter that's picked up by the receiver, which in turn then fires the flash via its hot shoe contact. So I've got 2 flashes set up here in the radio trigger mode. One is a very old unit which has got a very high trigger voltage of 250 volts, but that's okay with these triggers because they can stand that. If I was to connect that to the camera, either by its hot shoe or by the sync cord, it would damage the contacts or the circuitry in the camera because of that very high trigger voltage. So that was one way of repurposing this old flash gun, which has got a very high power, but unfortunately the trigger voltage was too high. So by using a radio transmitter and receiver system, you can actually repurpose those old flash guns. So now when I fire the camera, the transmitter will send a pulse, will be picked up by both of those radio receivers, and will fire those flashes together. So there we've expanded the system with the radio trigger. To expand the system, of course, I could add more slave triggers, more radio slave triggers, or a combination of optical and radio triggers. So we're only getting the 1 pulse to the flash unit, so they will fire just the once. It will be picked up by the optical trigger in the S1 mode, and now I can add the 2 radio triggers and the 1 optical trigger into the equation. So you probably noticed there that when the radio trigger is fired, the optical slave trigger saw those lights and then fired itself. So if I repeat that, radio trigger firing the 2 radio receivers, they in turn cause the slave flashes to fire. As soon as the light pulse was seen by the slave, it too contributed to the exposure. You can run into latency issues between the time it takes for the camera to respond to the transmitter responding to the receivers in turn having to fire the slave units, and that light being picked up by the slave unit in the optical mode, so the actual third flash might be a few microseconds behind the main flash. So if you've got any high-speed movement in your subject, you may see a strobe effect because of the 2 flashes actually in synchronicity. There's a slight delay between the 2, but for most purposes, if you're in a studio portrait type situation, you're not going to notice that delay. With the more modern radio receivers, such as the Yongnuo, they are actually multi-channel transmitter, so you can have 16 channels. You can then actually get Yongnuo flash units which have got built-in receivers, so you don't actually need to put a receiver on the hot shoe. They respond directly through the transmitter receiver of the flash unit. And you can get master flash units which actually allow you to set up those units remotely, so you don't have to go to each flash unit in turn and set its power level. You can do that from a master commander, and again Yongnuo are masters at doing that. With the more modern radio systems like the Godox system here, the X system, You can use the flash on camera as a master and another unit off camera as a slave, and they will fire over the radio waves, again giving that full control. So that's how to repurpose some of your old flash units on bridge cameras or DSLRs. Hope you found that useful. Now, I did write a blog article about repurposing some of the old flash guns, and I'll put a link to that in the video description below. Now, in that article it shows you how to measure your own trigger voltages from your old flash units, or it gives a link to a website which has got an inventory of all the flash units and their trigger voltages. So if they're under 10 volts, then you're probably okay to fit them to your camera without any possibility of them frying the electronics. But if they're more than 20 volts, then I would hesitate in putting them on the camera. Fit them to a radio trigger which has got a higher tolerance to the trigger voltages. So until the next video, I hope you found that useful. Please do take care, and I'll see you all in the next one. Goodbye for now.